Hello everybody and welcome to LightSyntax. How are you doing? Missed you guys so much. Okay, I came across a very interesting problem today. It's called interweaving strings. It's kind of algorithmical problem that is really fun and I'm really excited to show you guys. The problem simply gives us three strings, string A, string B, and string C, and asks us, hello, can you find if string C is composed of the interleaving of two other strings A and B? Uh, just counting the repetition of letters will not work. Uh, Let me show you guys. Hello guys again and let's do it. Okay, we've got string X, we've got string Y, and we're checking here to see if string Z0 and Z1 are composed of X and Y getting together or interweaved together. This is a very interesting problem and used extensively in the field of genomics and genetics. So let's check if this offspring came from parent A and B. So that implies that our algorithm, our implementation needs to be efficient as we're going to work with very long strings. So let's try our first brute force approach. We take letter A from string 0 and check. Came from X or Y? Obviously it came from X. So let's move along. A came from X or Y, it also came from X. D obviously came from Y because at the right index here doesn't match the thing, so it came from Y. B, let's assume it came from X for now. If it didn't work out for us, we'll assume it came from Y. If this didn't work out as well, we are sure that Z0 is not composed of X interleaved Y. So let's move along. Letter P came from Y, C obviously came from X, B from Y, and so on. C, maybe X, maybe Y, let's assume it's Y. A obviously came from Y, and lastly C came from X, and hallelujah, this works out. So string Z0 satisfies our condition and it really came from X interleaved Y, so that's a positive case for us, so a happy case. Let's try again, but this time with the other string Z1 that did not came from X interleaved Y, and see how our approach is going to differentiate them. Let's key our crossings out, and there we go. A came from X as usual. A also came from X. D obviously came from Y. B maybe X, maybe Y. Let's assume X. B came from Y, B came from Y. A did not we did not get, because neither X nor Y can give us A right now. So let's assume that the first P came from Y. And moving along. P maybe from X, maybe from Y. Let's assume it's X. And B obviously came from Y. A, we can't get A from neither X nor Y, so let's roll back and assume that B came from Y. Moving along, B obviously came from X. A, oh, we can't get A from neither X nor Y, and we have exhausted our chances. We've tried every possible combination, so let's mark this as false. So, what is the complexity of this algorithm? The complexity is obvious. It's 2 to power m plus n. That is not so good. Alright. Let's try. What can we try here? Obviously, we can solve the same problem over and over and over again. And if the thing got really wrong, okay. Obviously, the obvious thing to do is to use dynamic programming. Dynamic programming, we have, besides x, y, and the thing we're checking for, let's call it z, we've got x index, y index, and z index. Z index will always equal x1 plus y, xi plus yi. Okay, so that's kind of redundant to the x and y. We can build some kind of hash. Maybe simply we add them as a string together, we concatenate x and y, and every time we store a string that did not match our condition, we store it there in a set. Before doing any work, we check if this set contains the string I am checking for, or the indices I've checked for before. Yes, if it does exist, I know it didn't work out, because as soon as something work out for me, I am going to return. So let's see this in code. Hello again and welcome to LightSyntax. Coding. So here is the function that takes the C strings A and P, or A, P, and C, and it checks. Does C is composed of A and P? Maybe they are. So if the length of C does not equal the length of A plus B, we know for sure that string C cannot be composed of A interleaved with B. So let's move along. Here is just the set we are going to use for the memorization. And we call the interweaved function on A, P, and C. And all indices stands at the very beginning of A, B, and C. Also, we're going to pass the memo so we can obviously memorize what we are the cases we've gone through, so we don't repeat our work. Okay. Here I am composing the ID for the memorization. Simply the string A concatenated with the string B with this separator here, so our numbers don't get mixed up. If I find that I have seen this combination of A index and B index before, simply I return false. I've seen it before, and obviously it wasn't true, because if it were true, I would have returned to them. Okay. Here I have reached the last element in the system. Okay, what does that mean? I have not just reached, I have passed it. What does this mean? Means my job is done, we had no conflicts, the strings A and B definitely are interweaved from string C. String C is interweaved definitely from strings A and B. So we check, is index A lower than the length of the string A? If it is, we're fine, good to go. If the character in string C, we are checking on match the character in string A, we are checking in turn if it is. So we reduce the problem a little bit and we going one forward. So we've passed the index for A plus 1, the index for C plus 1, the index for B stays the same for obvious reasons. So we've crossed out character from A and character from C. Same thing here. If we are in range of the B range and we've got a match, then here we cross a character from P, character from C, and we redo our problem again. So if this didn't work out and this did not work out, we insert it as simply, sorry for that, we insert it as a false example. So when we get here again, we return immediately because we already done this work before. Let's test this out on some of our conditions. Okay. Let's first disable the memorization for a moment. If I did this would very much disable the memorization, so memo does not get passed by reference and see the results. Obviously, you've got the result for case 1, 2, 3, 4, but we did not get the result for 5 because 5 is a long string, and if I waited very long time, let's say an hour, I still won't be getting any result. As you can see, A, B, and C are really long strings. Not that long, but it would take some computationally heavy demand. So let's stop this out and enable our memorization again and see the results. Now it's building, compiling. Oh, that was fast. And it turned out the really long string wasn't actually interweaved. So these are the first cases I have used we tried some combinations to really see, sorry for the scrolling, my graphics tablet were going crazy, so here we are. Thank you for watching, everybody, and be sure to share these videos your friends if you were interested in it. Hit the like button and don't miss an episode of LightSyntax. I promise there is going to be another one, and thank you everybody. Thank you.